Alright, such begins another streaming session. This is session number 6 for me, and tonight I'm going to be working towards finishing the URI component. So I was reviewing what my past work was and looking at the RFC, and to handle things like resolving relative references, we're going to need to implement the remove dot segments algorithm that the RFC talks about, and this will be used in 2 new methods I want to add. Normalize path, which I want to be used for absolute paths, because the RFC talks about that it's a good idea to remove single dot and double dot path segments, even from absolute paths. And then resolve method, where we take 2 URIs, a base, which is absolute, and a reference, which is relative, and merge them. And you can think of it as the same as if you have a path on your computer to a file, absolute path like C:/program files, and then you apply a relative path to that, like /temp, it'll get resolved to C:/temp. So this is the same kind of thing for URIs. We need to implement that. After that, I want to kind of take a crack at IPv6 address checking. After that, I think I left one of the more obscure parts of URI in the to-do. I can tackle that, or go to refactoring if I have time. Or I mean refactor if I don't have a whole lot of time. If I have a lot of time, get to more of the URI to-dos. There's a few more obscure things to implement in URI parsing, and then URI generation. All right, so let's get to it. So first I want to establish the new method normalize path. We'll do that first. And I was looking at the RFC, where they talk about remove dot segments. This is essentially what we mean by normalizing the path. So right now in our code, we're just kind of assigning things as is after we parse them: scheme, authority, path, query, fragment. They talk about running this algorithm called remove dot segments. And they provide some pseudocode for that. There's a pseudocode right here. And it's all talking about removing dots and dots. And they even provide some example inputs and outputs, which I'm going to shamelessly steal to put into our unit tests. In fact, that's what we're going to start with. So let's go to our code. All right. And then go to our unit test. I have a lot of tabs open. Let me just clean up my tab list, close them all, scrunch everything, and then we're going to focus on our tests. So let's make a new unit test with a vector of test cases, or test vectors. So this is all about path. So we're going to just focus on the path segments. So we'll have our input path segments. Do I want to have input path segments? Actually, why don't I just have it parse the URI first and leverage just being able to write it as a string. And then the output will be a path segments. It'll be normalized path segments. So this is all about normalize path, or whatever I called it, whatever I wanted to call it, normalized path. So our test vectors are going to be kind of copied from the standard. And they say the output for that. Actually, I guess they just gave us one test case, didn't they? And they're reducing it in steps. So our output's going to be that. So it's absolute path, A and then G. And then this other example here ends up in that many steps to mid/6. So mid 6. That's good enough for now. There are probably other examples in here. We can pull them in later. So here we're going to do something slightly different than we've done in the past. Instead of just parsing and then checking something, we're going to parse and then we're going to call another method. And let me think for a moment. Is this going to essentially fail? No, it doesn't fail. It's going to return void, so we just call it normalize path. Now we're going to check that the path matches the normalized path segments, whole path. All right. So again, we're using test-driven development. We write the test first. It doesn't even compile because we don't have that method yet. So the next step is to add the method in the header file. And I guess we can add it near the end. Normalize path, or I'm going to actually change the path so it's not const. This method applies the remove dot segments routine. Talked about in, and here we'll make a reference to the RFC. To the path segments of the URI in order to normalize the path. Remove dot and dot dot. Really, it's apply and remove. Apply and remove dot dot dot, dot and dot dot segments. Okay, so now it will compile but not link because we don't have a definition of that method. So next is to link, to add the definition so we can make it link. Now it will link, but our test will fail. Again, I'm following the test-driven development procedure. And that, by the way, was my little macro that I have. If I need to talk to someone in the background, if there's a loud noise, I'll temporarily mute my mic. So now our test failed because it's not normalizing the path at all. You can see it didn't remove the dot and dot dot segments. So the last part of TDD, test-driven development, is you change the code to make the test pass. So let's think about how we're going to do this. Actually, we don't really have to start with nothing. We can look at the standard and they give us pseudocode. So we're going to have while the input's not empty loop as follows. So we need to think, what is the input? The input buffer is initialized with the string, with the path components, and the output buffer is initialized to the empty string. So we're going to have the input. And let me think about this. So the path is in a vector of segments. So let's just move it. We'll move it here. Old path. Move path. And it's in our impulse, so we need to move it out. And then we call clear on the path that we just moved so we can reuse it. So this implements step 1. Step 2 is while it's not empty, loop as follows. So while not old path.empty, and which implies we're going to be changing it, so it can't be const after all. If the input buffer begins with the prefix dot dot, or dot, or move it. So if old path is dot, or old path is dot dot, Then we remove it. So remove is easy. We just say old path erase, old path begin. That's step 2A. So, and then otherwise means we're going to do an else. If the input buffer begins with slash dot slash or slash dot, or dot is a complete path segment, then replace that prefix with slash in the input buffer. So the way that our code implements slash dot is a path segment that's empty followed by a path segment that has a dot in it. So we can encode that as if old path that size is at least 2 and old path first element is empty and old path next element is dot. Then it says replace it with just slash. In other words, we're just going to replace it with a single empty string. In other words, erase the second element. Erase old path.begin plus 1. Otherwise, so we have another else. If the input buffer begins with the prefixes slash dot dot, or slash dot, where it's a complete path segment, this really tells me the same thing. Then replace that with slash in the input buffer and remove the last segment. And its preceding slash in the output buffer, if any. Okay, I'm trying to understand this. Okay, so it's basically the same as 2A, except we also remove the last thing we put into the output buffer. So it's this, only it's 2 dots, and we do that plus the new path is impl path, is we erase its the last one, which is, I guess we're filling it. Let me think about this. Filling it from the end, so we're erasing the last one. Actually, I can cheat and say r_begin. I think. Can I? Oh, I'm sorry. Path.r_begin. Oh, you can't erase. Okay, I guess I can't do that. So erase begin plus size -1. That's what. So it erase the last one. Or is there an easier one like pop back? There is. It's even better. Probably I can also say here pop front, right? No, can't say pop front for a vector. I can pop back. All right. Hopefully I'm understanding this pseudocode correctly. We'll be able to test that with our unit test, right? If the input buffer consists of only dot or dot dot, then remove that from the input buffer. Okay. So that's else. These are all otherwise, so it means that they're all separated by else if. So here, again, if it's only dot or dot dot. So in other words, if old path, hold on, wasn't it the first? Is that, isn't A and D the same? I don't understand that. If it begins with dot dot slash, then wouldn't it also, oh, consists only of, meaning it's the last. Okay, I don't quite understand why, but we'll see what happens if we implement the standard as it is. So only of means the size is exactly 1. And it's either a dot or it's a dot dot. Then or remove it from the input buffer. So that's this again. Otherwise, move the first path segment to the end of the output buffer. So move the first path segment to the end of the output buffer, including the initial slash if any. So if that means if, okay, but not including the next. Oh, I think I know why I'm having difficulty reading this. This is talking about processing it as a string, not as a list of segments. So I have to be careful about that. So basically they want to remove the first element, but if it has a slash, meaning if there's an element after, we need to keep it in there, which would be the same as, instead of erasing it, replacing with empty string. So that's this else. So input path, move the first to the end of the output. Is that right? I guess that's right, because, yeah. So push back old path 0. And we have to be careful here. If old path size is greater than 1 and old path, actually, if that means that there's a subsequent slash, right? I have to be careful about this, including the initial slash. That means it could be the second. Actually, the way I'll handle this is, first we do the check. If the old path is equal to empty string, then we're going to push that and then remove it from the old path. First path segment. I'm wondering what happens if the path is just slash. This is going to be a problem. Thinking. Well, it seems to me that if the path, you only do the rest of this if the old path is still not empty, right? And then you push back that element, and if the next, not including, okay, yeah, so if there's more than one element left, then you want to just clear the input path. I'm sorry, the input path is old path. Otherwise, I think we just remove it. This seems awful hokey. And finally, okay, so I have no idea if this will work. If it doesn't work, I might just kind of ditch what the standard says and kind of do it based off of the specification before it. Okay, it didn't work. Didn't work at all, did it? So, just out of curiosity, let's step through it and see what's happening. So, old path's there. It's slash A slash B slash C slash dot slash dot dot slash dot dot slash G. right? Oh, and they had steps, so we can see if their steps are correct. Right, so the first one, it's going all the way to our else, right? And it does have a absolute path, so in other words, a leading slash, so it's going to insert that in the output and take it off the input. And if it's not going to be empty, so we push back, so push back into the output, the A, and then clear it. Right, so I think we're good so far, because now the old path, in other words, the input is now slash A slash B slash, slash B slash C slash dot slash B. So that's correct. And our output buffer, which is the impl path. Let me set up a watch for this. So old path and impl. Old path down, impl path. So the new path is, or the output is slash A. Slash A. Okay, so far so good actually. So loop number 2, it's going to go to our else. So it's going to, oh, I see the problem. It's going to just insert an empty element there. So we have slash A slash B. So we don't want to do. So we really only want to do this part if the output is empty. So if old path is that, and impl path, oh, what happened there? Empty. Let's see if that fixes it. Actually, we've gotten to an infinite loop now. Oh dear. Oh, I put the logic in the wrong place. The logic is the condition's fine, but we only want to push back an empty path if it's initially empty. Right. Okay. Actually, it made our test case pass, so it looks kind of gross, but what we can say is this implements the algorithm from the standard. I kind of like being able to say that, so we can say this is a straight up implementation of the algorithm from section, what section are we in? 5.2.4 of, and then repeat the reference. So hopefully we've written it in a way. In fact, I'll annotate it a little bit more. We'll say that was, this is, let me make that stand out as a multi-line comment first, with a little bit of a border around it. So we could say this is step 1, and then step 2, step 2a, and then I can break my ordinary rule of keeping it on the same line in order to put a comment here. Step 2b. So this is basically a code translation of this line. It's the if and then the otherwise meaning else. So it's straight up verbatim translation. Step 2c. Step 2d. And then 2e, right? Yeah, so the formatting is different from my normal formatting because I want to kind of call out that it matches precisely the steps in the algorithm. And we omit step 3 because we were building it in place. I suppose what we could do is make a free function called remove.segments and then call it, and then step 3 would be the return. It's sort of a silly thing to say that, I think. Anyway, I didn't break anything with that, I hope. All right. I think what I want to do is add some more test cases just to get some more confidence. So let's search through the RFC first to see if they have. Oh yeah, they had that, and we did run that test. Forgot about that, so we did pass that. I wanted to make sure steps 2A get hit, 2B and 2C and 2D, all that. I don't think they are. See, that 2A logic's not hit at all. 2B is hit. How was that hit? Okay, it's hit. It's hit with this. In this string, we end up in 2B at one point. Let's see if we ever hit 2C. Okay, 2C is hit also, probably in that same test. Yep, in the same test. And is 2D hit? So 2D is not hit. And we're pretty sure we were hitting 2E, right? So we kind of want to have test cases that hit 2D and 2A. And you could think of that as getting better code coverage. So let's try to do that. I think what we need to do is just have a path that starts with dot. And let's see if the RFC talks about anything like that. This is for resolving based off of a base. Okay. We could make a unit test for that, which would be kind of interesting because we test both the normalization of the path and the normalization of the upper versus lower case. And then we should be able to compare URIs. And that brings up another thought. We don't have a comparison operator for URIs. So that's actually 2 good reasons why we should actually add a test for that. So let me hold on, before I do it, I'm going to check in the code. But after we check in the code, I'm going to make a special test case for this just because I kind of like that. Let's see. Go to our Git terminal. So straight up what we did is we implemented normalize, or not just implemented, but we added, it didn't exist before, added normalize path. You don't want to say past tense, you sort of want to be imperative case in git commits, add normalize path method. So let's go ahead and make a test case for that interesting one from the standard. Maybe I'll even name it after the standard. So we're calling this syntax-based normalization in the standard. I don't really like that name. Right, I'm going to make the test named around the 2 things I liked about this, which is it's testing normalize and it's going to test comparison. So normalize and compare equivalent URIs. And we'll have a comment here that this was inspired by section 6.2.2 of the RFC. This one. So we're going to have 2 URIs. URI 1. I just thought of something else. Wouldn't it be desirable to be able to construct it from a string? Well, we'll say construct, normalize, and compare equivalent URIs, right? Why not? Because we kind of want it to look like we're naturally telling a story. So given URI 1 and URI 2, we already see that UR1 is normalized in its path. UR2 isn't, right? So we'll normalize it. Hold on, there is a problem with constructing from a string. If it fails, how do we know? Good thing to think about. Let's hold off from allowing that because it's problematic in how do you construct from a bad string. I don't think it's too much worse to say first give the names and then we can actually do assert true that we're going to parse them from strings. It's not too much worse. We normalize UR2 and then we're going to assert equal URI1 and URI2. Okay, let's see what that does. So it doesn't compile because there's no comparison operator for URI. So let's go add that. I'm thinking I kind of want operators to be somewhat near the top in the list of methods, so we'll put it near the constructor. This is the equality comparison operator for the class. And then the input is going to be other. This is the other URI to which to compare this URI. Return values an indication of whether or not. I really should take this and make a snippet. Oh, hi, Reliant Monkey. Should really make this a snippet so I don't have to manually type it. I type it so often. I need to add that to my to-do list. Learn how to make code snippets in Visual Studio. An indication of whether or not the two URIs are equivalent. Or equal is returned. So it's bool operator equal const URI other. And oh, that's not 1 equals 2, isn't it? All right. We will now compile. It should compile but not link. Let me just verify that. So compiled. Still, I think it's because I need to make that const. Let's make sure that that compiles. It compiles but doesn't link. So let's add the body and make it link. All right. It's fairly straightforward since we can take advantage of the fact that the elements all have intrinsic or built-in comparisons. So let's just go to our, where did I put it? It's in here somewhere. Here we go. The body of our impl. Just so I don't miss anything, I'm going to copy paste all of the properties and just paste it in there. And we'll just go one by one. So return that the scheme is equal to the other scheme. And it's going to be impl in front, isn't it? And then impl hosts equals other impl host. Oh, it skipped user info, didn't I? User info host has port. And actually, we only want to compare the port if they both have a port. Doesn't matter because if they both don't have, oh no, if they both don't have a port, we don't want to compare the port at all. So if see how do I word this correctly? So it's and they either don't have a port, or they have a port and their ports are equal. All right. That handles the port number. And then, and path is the same. It's going to be path, query, and fragment, right? So 3 more. Path, query, fragment. Yep. Cool. So it actually worked. Let's assert that they're not equal until they are until the second one's normalized. And that actually brings up that the compiler in C++ is not smart enough to simply call the equality comparator and then invert the result. Don't know why. It ought to be defaulted. So we kind of have to do it ourselves. Called the inequality comparison. Are not equal. But there is a way we can cheat. We can simply return the inverse. We can say return this is not equal to other. I'm sorry. That would be infinite loop, wouldn't it? So return not that the two are equal. Great. Another thing that might be convenient later is if we ever are making a sorted list of URIs, we're going to need the comparator. What did they call it? Less than comparator, I guess we'll just call it. I know there's a better word for it. I can't think of it though. Maybe we'll leave that for later. I'm thinking about it though. The test case is going to be a little bit long to write though. Maybe I'll put it in my notebook to add later. To do URI less than operator would be nice to have in order to make sorted sequences of URIs. So keep that as a note for later. Let's just check what we have in so far. We did 2 things here. We coded the neat example in section 6.202 of the RFC. And I'm already thinking this should be the body of the check-in. We did that, and we also add equality inequality operators for URI. And the summary for that is add capability to compare URIs. Compare URI objects. Okay, I got a little sidetracked from before. Before we were doing this equality stuff, I was looking at the standard, I think, and I was looking for more examples of normalizing paths. All of these ones are related to resolving a path based on a base. And I saw that one. You're right. I was going to look through and see if there are more. I'm not sure if there are. But we can invent some. Yeah, there aren't any. Maybe from the top there were some. There's some interesting examples here. The Rally Monkey says, sorry, I wanted to ask a few minutes ago for you to elaborate on what you were saying regarding the limitations of C++ when it comes to inequality. Oh, I was just saying that when we define the equality operator, and then we did something like in the unit tests, we asserted that they're not equal. I think that the compiler should automatically just use that and take the result and invert it, but it's dumb. It says, oh, you don't have a not equals operator for your class. So we have to declare it, and then we have to give it a body, but the body's sort of cheesy. It's just saying use the other operator and then take the inverse of the result. Supposedly it's to give you the so-called freedom of defining equals and not equals separately. I don't really see the point because they ought to be inverse from each other. So that's all I was saying. Right. Well, here's the example that I pulled into my notes. Oh, I think I saw a little bit of it. Okay, they talk about dot segments. Was the equals was reserved for something? Oh, I think it's handled by our character classes, so I don't have to worry about that. I'm just glancing through the RFC to make sure I'm not missing any cool examples of relative paths that I could put in our test vectors. I don't think they have any anymore, so let's come up with a few. Let's say it's http example.com, and then we happen to have a path that looks like a.b. So we should expect that the normalized path is /b. And I'll go and find the RFC example for this. I think they do it at some point. Say if you go too high up, it's just like you ignore that it was there in the first place. So that should be equivalent to that. Let me make sure right now by search. I'm going to search for ... I remember it has something to do with that. Oh, that was right there. Hierarchical processing has no effect on absolute URI unless it contains one or more dot segments. Can operate on opaque identifiers disallowing slash characters. I'm just reading here. Okay, it wasn't here. It wasn't in this algorithm. I thought I read somewhere where it said to guard against, and maybe this is it. It's just saying to beware older implementations will do something weird. This might be it here. Oh, maybe not. I thought they might have something where if it's here it's 4 levels. If they tried to go, if you go 5 levels up, maybe it's under abnormal. Oh, here we go. Here's where I read it before. You have to be careful in handling cases where there are more dot segments than there are levels. So they're abnormal, but they're not illegal. It's still legal. It's you just want to prevent it from going too high. You don't want to change the authority component, in other words. Right, it was A, B, C, D. So, right, this is the highest you can go up 3, right? You can get rid of B, C, and D. That's interesting. So they don't want you to remove they don't want you to. All right, that's because it's not part of the path. The path is actually /B/C/D. So would you exceed the ceiling and surpass the authority? That's what they're saying you want to avoid. The way we've broken it up, we're pretty safe because we've parsed these separately already. So the path would be /b/c/d. So you could go up 3 levels and you'd be at the root. So they're just saying if you tried to go up 4, it's the same as going up by 3. You hit the ceiling, and it's not an error. It just results in the same as if you did not have that 4th step. So let's make the same kind. That's what I was doing here. If from the root you try to go up, we can be more specific like they are and just say /a/./b. My doggo is barking in the background. Sorry. So we can put the regular one, the one that doesn't need any special processing there, to be very specific that either way it'll get you just /b. I apologize for the barks that get through. All right. That should still pass. I don't think I'm going to end up breaking our code. I just wanted to build more confidence that it's correct. Oh, it broke. Doggos. All right, so we can easily see this, I thought. Okay, there we go. Okay, what was the error again? Vector empty before pop. Okay, so was this one of the test steps that steps that we didn't test? It might have been. So it's /b and the old path is completely empty. All right. Let's see what that step 2c was. Input begins with okay, they had the if any. And I didn't have a check for that if any here. That's what it was. I had that in one of these other steps, right? I think it was this one. Oh, it's not exactly the same. It's a similar thing though. So it's if it's not empty, pop the back of it. See, it's good to add test vectors. Okay, we're back to not crashing and passing again. Really wanted to add cases to hit all these steps. Let's put breakpoints on all of them. We'll see which ones get hit again. E. Okay, E's good. B, C. So A and D are not hit. So let's craft an example that matches to A. 2A is where we just start with a dot. So dot/A. Now, I think that should just be A. Well, even add a B just to make it so it's not a loner. Let's try that. Okay, so it hits 2A. I actually didn't see if it passed or not. It does pass. So we're good with 2A. So 2D, let me read the text for that. If it inputs only dot or dot dot, then remove that. Right, I was thinking before, isn't it the same as 2A? Okay, this one's talking about removing both. Removing that prefix, which so it would be the slash as well. So it'd be removing that, which it does. And this isn't if it's okay, if it's only that. So that would be like if it's trailing or if the string is Okay, two ways you can get that, right? You can either have it just that alone, which would be nothing, or it could be trailer. In that case, you just want it to eat the last one, right? See if that works. Okay, it didn't work. It didn't work because, oh, I didn't print out which one, did I? Print out our index here. 7, right? Well, okay, expected. 1, 2, 3, 4, 5, 6, 7. Okay, dot doesn't end up. Yeah, it became an absolute path somehow. Is that a bug in 2A? Yeah, I think it is. Right? Oh, right. That's gonna match just the string dot. Right. So this is where it specifically has another segment afterwards. So it's if old path dot size is greater than 1 and this stuff. I'm actually thinking it's greater than 1 means greater than or equal to 2, and doesn't that intersect 2b? Maybe I'm not reading. Oh no, that's if it's actually this is technically 3 elements in it, right? 1, 2, 3. Oh no, I think we're fine. Okay, still not good. So in that test case, it's just dot dot. Oh, hold on. I don't have that right, do I? That it's actually an empty path. Yeah, so there either dot or dot is meaningless, right? It's not an absolute path. There's no path segments at all. It's just a null path. Okay, so I think we're good there. Let me make sure we hit all our test cases, our steps, I mean. All the code paths are hit. 2E, 2B, 2C, 2A, 2D. Okay, so they all get hit at least once. I'm still kind of not really happy about this code because I think it looks kind of weird. I'm trying to be true to the RFC though. To build up more confidence, I think I want to build some more corner case checks here. How about if I have just a single dot? That should keep it at keep that B at the end, right? And what if we had something after that, like a C? Actually, we'll try both of those two. C and then a slash. We kind of want to have an empty element after. Okay, those are all still good. Then how about if we have all of those, but with a slash in front? How about a couple different things here? Those are all absolute path equivalents of that, and then right. All with a dot in front. Those are now all relative again. And actually then the dot should be the same thing. Why didn't that empty string in the test vector a moment ago serve the same purpose as a null? Probably would have been a better idea if okay, I'm trying to understand your question. Let me read it again. Well, okay, why didn't that empty string in the test vector a moment ago serve the same purpose as a null? You mean this? Oh, my stream is pretty delayed, isn't it? Yeah. That's an empty vector. Basically saying there are no segments at all in the path. But what I had earlier was a single element, so that's a vector of size 1 with a string that's empty. That's a vector of size 0, so there's no strings at all. One with the size of 1 would be a single slash. Right? Okay, good. All our test cases are passing. So this is building up confidence for me. We're doing all sorts of weird corner cases. Let's add another one in here. Let's put a dot dot there. That should get rid of the B part, right? Let's do it. Let's do with both. Dot slash, right? The dot slashes should be just completely ignored. So if I put them in either place, it should just do the same thing. Yeah, okay. I think we're probably pretty good. Did any of them end in a dot? Okay, yeah, these ones ended in a dot. And ended in a dot dot, beginning with dot dot. How about slash dot? I don't have any of those, do I? So like a slash dot slash a, getting too many A's and B's. How about C and D? That should be absolute path. Ignore the dot, so we just C and then D. And how about a dot dot? The dot dot should be ignored because they're already at the root. And then leave the C and the D. We're all still good. Just because I hate seeing tests continue to pass, let's break it on purpose. If that still passes, then we know something's dreadfully wrong. Okay, that failed. It's never bad to do that once in a while, just to make sure you haven't completely sabotaged your test framework. So I'm feeling good about it now. Even though the code looks strange, I have in the code those comments saying that it's written this way to match the standard. In fact, how did I word that? This is a straight up implementation of the algorithm. That's what I'm saying straight up implementation to excuse the fact that the code looks a little weird. So we added a bunch of test vectors. And that's separate from fixing a bug, wasn't it? Actually, I'm wondering, did we even need that logic at all? I did that change thinking it was fixing a bug, but it was a different bug, which was this one, right? Definitely that bug was caught by one of these test cases we added. Tell you what I'll do is I will stage all that and I'll unstage this part of it. And we'll stash that. Actually, you know what? Did I have some stash from before? Need to remember how stash works. Stash show. I do. I had stashed some work in progress and never got back to it. How do I show? Is it show? And then dash P? Right. Oh, yeah, I had started converting that initialized list to character set, and I stashed it to go back and do something else. When I went back to character set, I ended up doing it over again. Completely forgot that I had stashed it. So we'll have to show okay, we're showing two things now. How do we abandon a stash, and then how do we pick back up a stash? So I'm going to abandon this old stash. That's simply stash drop. And in case we make a mistake, we can always get it back by resetting to that. Or we can do git reflog. And it should still be in the reflog if it was recent, if it was recently stashed. I didn't recently stash it, so the only way we can really get back is if we reset to that. Okay, and then the thing I did want to stash and then get back later. Make sure that it's okay. So I want to stash that in case I still need it. And I want to test first without it. This part I definitely want to at least make a commit for, because I don't want it to go in the stash. So we're going to call this add more path normalization tests and fix a bug in it. And the bug was, right, so for normalization step 2C, if the output path was empty, we don't want to pop the end of it off, because that's a bug. Can't pop the end of an empty list. So when I make that commit, now we just have that unstaged commit. We can do stash to move it off. Now it will, in Visual Studio, say that there was a change, reload it, yes. Go and I build it and run the tests. Okay, so that change that in step A was not needed. Okay, yeah, I was looking at it wrong. I thought A and C were intersecting each other, but this is if the first element's dot dot, and that's if the second element's dot dot. And the first element is nothing, first element is dot. So they are different, and I didn't need that check at all. So here's, okay, well, first let's pretend we did want to change. I'll just show you how to get this, how to get the stash back. Like, once again, it's stash show. Oh, wait a minute, hold on. Did I not stash it? I did stash it. Oh, I'm not in the right shell, that's why. Git stash, got stash, git stash. Best to see if you have something, and if you wanted to see what the patch was, you can see what it is. It's like, if we want it back, we do git stash pop. Pop versus drop. So you have to be careful not to do the wrong one. Stash pop puts it back into our working directory, so we'll end up picking up that change. Now it turns out we actually don't need that change at all, so I'm going to get GUI, just hit Control J, revert, and now it's gone. I can actually get it back if I really needed to by resetting to that. Actually, let's see if I'm right. So git, I think it's reset. Actually, I'm not sure, because we don't want to get it back into our commit history. We want to get it back into our working directory. I'm looking at the list of options, and I think it might be git stash command. Actually, maybe you can't get it back. What's the describe? I don't remember it. I know if you look at /git head or whatever that point to refs heads master. So it is different from that. So what happens if I reset to that? Git reset hard and then to this revision. Do I get that stash back? I do. Oh, not git GUI, git K. We get it back as if we had actually committed it. Interesting. So we can get it back if we wanted to. And then I'm gonna do ref log just so I can undo the reset that I just did. So we'll just reset to head at 2, right? Right. Okay. Some somewhat hardcore git commands that we're doing. Test still passing. Side question for Git. Is there a way to push a stash upstream with no committing? Well, pushing upstream, it's an operation on a commit. So no, you have to make a commit. Making a stash is actually making a sort of a commit. It's a commit that's kind of off to the side. And you could kind of see that briefly if you're looking at the git K. It was showing WIP for work in progress. It has a special name branch. So the equivalent of what you're asking would be to make a special branch, put a commit there and push that upstream so that it's also a separate branch upstream. You know, like what we're in now is the master branch. So if you had some uncommitted things, you could create a new branch, check it in, push that upstream as a new branch, and then go back to master. And that's the equivalent of stashing it. But more formally, you're putting it into a separate branch. You can then get it back by merging that branch back in to master. Stash is more of like a quick shortcut. Usually it's just git stash, and when you get it back, you do git stash pop. Sure thing. All right, so am I happy with this? I think so. So we can knock off that from our list for today. We have normalized path. Okay, resolve is next. We're going to do a very similar thing because we already implemented this remove dot segments in the form of normalized path. What we're going to introduce is the concept of a base URI, and we're going to use the logic that's in the RFC where they talk about resolving references. This is all under the section called relative resolution. So the idea is that you have a base URI, like the address of your web server might be, let's see in their example where they would have an example of that. Okay, right. Reference resolution examples. So here's the base URI. So for example, let's say you went to a web server and you gave it this request. So this is literally requesting of the A server, the A host or server, to go to its /b/c/d directory. Actually, it's the /a/b/c /p. So that's actually one element, one segment. It's going to that resource and then giving it as in looking up that resource with a side query of Q. And let's say you get that back to the web client, and the web client is a hypertext, is now holding a hypertext document that was retrieved from that request. And in that hypertext document, there are some relative references, like references to where to get images that are associated with that document. But those URLs are all relative references like these. How would the client ask the server for that? Because I'm not explaining this right. Knowing that the reference to, let's say, G:/H is made from this reference, where do we go to get that thing? We would have to go, we'd have to go back to that same A server and ask for GH in relative to the path we were looking at, which was this. And that's what reference resolution is. Oh, actually, the G:/H is a bad example. because the colon is rewriting the scheme. This is a better example, right? So if you were at /b/c/d semicolon p and you asked for G, the resolution rules are you go to the directory that last thing was in, which was /a/b/c, and then you look for G under that, right? Or if it was // you would go up to B. But otherwise, it's all based off of the original request. All these are based off of that. And you can also think of it as taking the original and mutating it or navigating it based off of a second path. Oh, hi, Lumi. What's going on here? I have actually a little title for that. I'm working on a month or 2 month long project here to make my own web server in C++. So what I'm doing today, I'm working towards finishing a component called URI, and that's parsing web addresses. And I'm using test-driven development, so you'll see me working on unit tests and then trying to make them pass. Yeah, exactly. Like, how do you pronounce that? I've never known how to pronounce that. Nginx or Apache? Yeah, exactly. So this is like broadcast number 6, and I'm thinking in another month or two I'll have the equivalent of a light version of Apache going. Nginx. Nginx. Never thought of it. Yeah, you're right. Exactly. So I was just working here on combining URLs. So given a web address like that, and then you have a relative reference to it like that, how do you resolve it to that? And the standard document for URLs talks about how to do that, and they give all these examples. So we're going to add that to the class that we've been building. So let's do that. So first thing we do in test-driven development is we start with a test. So let's make a new test to cover reference resolution. Reference resolution. And we're going to need to fit this test data into our test vector. So we have a base URL. Let's put that in. Const standard string base is that. And then we have all of these different relative references. So it'll be relative reference string, and then what we expect out will be our URI. Actually, I don't have a constructor of URI from string, so we'll make it string, and we'll parse both of them. Target. What they call when you resolve a reference, they call that the target. So let's codify all of, not all of it, we'll get a few and then we'll put in the rest later of these examples. So given a relative reference of that, we expect a target of the same thing. And okay, G is just that guy. We'll just start off with 2. Just to get the ball rolling. So what we're going to have 2 URIs, right? The relative reference URI and the target URI. Parsing the relative reference URI from the relative reference string. And we're asserting that both of them are parsed correctly. So target URI is parsed from target string. I should say string. Okay, so what we're going to do is we're going to take that relative reference URI, and actually we forgot to make that into URI, the base string, and then URI, base URI. assert that we are able to parse it from its string. So let's write it how we actually want the code to be. It's not going to compile, but we'll make it compile. Really what we want is a new URI called, well, actually, there are two target URIs, right? So this is the expected target URI. And then we'll have the actual target URI. So we want actual target URI to be the base URI resolve the relative URI, relative reference URI. And I actually am gonna have it get the type automatically. And we're gonna assert that the two are equal, that the expected target URI is equal to the actual target URI. So a lot of this already will compile, but resolve won't because we didn't define that method yet. So next step in test-driven development is we go define that method. Let's add it down here. And what we want is, we want it to return a new URI. It's going to be called resolve, and it's going to be given the relative reference URI, which we don't want to modify, so it's constant. Relative reference. And we don't want to modify the base either. I like to document first, so this method resolves the given relative reference based on the given base URI, returning the resolved target URI. Parameter relative reference, what that means, this is the relative, how should we say it? This describes how to get to the target starting at the base. And what we return is the resolved target URI is returned. Okay, so now we have declared the method. It will compile but not link. And I screwed up. Oh, because I didn't... Did I have two tests with the same name? What did I do? Did I accidentally duplicate that test? I did accidentally duplicate it. How did that happen? I think I just accidentally copied two tests instead of one. So verify compiles and doesn't link, and that it still doesn't compile. So, alright, I see it is saying that it wants to use the move operator, and we have not allowed that. So let's allow that. I like to make things like the copy and move constructors not allowed by default, and then allow them if we need to. So we'll allow the move semantics, and we'll define those. Define them later, because right now we're just making sure it compiles. It won't link, so now we're going to make them link. So three things we have to do to make it link now. We introduce the move semantics. Put that near the destructor. There it is. And I think we can just leverage the default. I think that will be sufficient. And then the new method we added. Clumsy on my keyboard today. And we just do the minimum to make it link. So return, let's just return this. Okay, it doesn't want to copy a URI. All right, well, we'll probably need to implement that anyway. I just want to actually see the test link, but not run correctly. So right, it doesn't run. It's weird that it's, because we didn't give Google Test a method to actually print out a URI object. That's why. That might be a good side project. Let me put that in my notebook. I'm going to put that under to do. Oh, hey there, Adam. Failing test how this stream is a stream I can get behind. Yeah, I'm using test-driven development. So the rule there is you want your test to fail first, then fix the test, and that's how you know it's working. Glad to see you here, Adam. I don't have a nifty shout out yet, but anyone who's browsing here really should check out Adam's channel when he's around. Let's see if I did that right. Okay. Oh, and I got my purple Botland shirt today. I'm sorry I don't have a face cam yet set up. I could show it to you. All right, I was going to my notebook and I was going to add a to-do list here. I think it's called a print to. Add a print to method for URI so that Google Test knows how to show us URIs in test failure messages. That's a fun side project for later. All right, so we're in the cycle of test-driven development where we have our test and the test is failing, so we're going to need to make our test pass now. So how do we resolve URIs? The RFC gives us the instructions to do it. That was up here I was looking at earlier. So we really just need to code what the RFC says. It's really nice when RFCs do that. So I'm going to start off by saying we are going to be resolve the reference by following the algorithm from section 5.2.2 in the RFC. All right. So following that, if defined, really it's for us the equivalent is if the relative reference get, well, we don't have to use the accessors. We can go straight into the implementation. If the scheme is empty, it's the else. I'm going to stick to the same structure as the RFC, even though I really don't like doing the negative check for the if and the positive for the else. But I want to match their pseudocode. So the if part, we're going to be building the target, by the way. And we're going to be returning that target. I don't need that resolution thing there. Target.scheme. I'm just going to copy this. Why not, right? Is the relative reference scheme. Authority, we didn't call authority. We have that broken up into three separate pieces. Well, perhaps I might be casually explained. No, I'm not, but maybe he has a nice deep voice as well. You'll have to forgive me if I'm not very good at streaming. This is only the 6th time I've ever streamed. I've been doing coding a very long time, and a lot of it in C and C++. A very little of it in JavaScript, and that's one of the reasons why I was looking at your stream, Adam, because I want to learn more about JavaScript, especially the React framework. But I've been doing this kind of coding a long time, but usually I'm doing it solo and I'm not interacting with other people. So the streaming aspect and the interaction is all pretty much brand new to me. Thanks for the link. I will check that out later. Although for me, it's still really weird to hear myself speak. Okay, back to this authority. We had broken up into 3 pieces. That was host and user info and port. And port had to be into 2 parts. It either has a port or it doesn't, and if it does have a port, it's a port number. Okay, I removed that. We have a name for that, right? Which was normalizing the path. After doing that, so we normalize it. Streaming takes some time to get used to. Yes, it does. I'm learning that out firsthand. What I really don't like is saying a lot. And I listen back to myself and I cringe every time I hear myself say but I'm working on it. All right, so next part of the pseudocode. Define, okay, so I had a rule for that. I really should make that a function, but the rule for if the authority is defined is if, that's relative reference, right? If the relative reference's host is empty, then it's not defined. So if it is defined, then it's not empty. And then there's going to be an else, if, else. All right. We'll do this part first. Okay. That was all of this part. Again. This is pretty much that, except for we're not moving the authority, isn't it? I mean the scheme. I really want to write that better, but I also want to be true to the standard, just because I think I'd want to be able to compare with the RFC and say, yeah, that's what I'm doing. So I'm gonna, even though it's kind of weird and looks redundant, I'm gonna do the same thing in 2 places. The only difference is we're not copying the scheme. All right, else, if the path is empty, if the relative path reference path empty is path empty, then this. Start cheating, copy pasting here. Define query. All right, so defined is if the query is empty, not empty, then copy it. Okay. Otherwise, get it from the base. The base. Base is this, so it's just ample query. Else this part. And we're gonna have to add to not forget that there's a part 1 level up as well, which is this one, and there's actually another one from the previous level up, which is this. And the fragment, last but not least. Okay, starts with slash. For the equivalent for that would be that our path is, okay, size is not 0 is the same as not empty. And the first element is an empty string. Then the target path is, okay, remove dot segments from the relative path. That's the same as saying it's equal to the relative path and then normalizing it. Else, okay, this is one thing we haven't done yet, is merge. And I have an idea of what they mean. I believe we're already doing merging in the form of the, oh, no, we're not. Merging, I think what they just mean is concatenate. Yeah, I think that's what they mean. So to concatenate two vectors, we insert, see if I get this right. Oh, it's copy. Well, first we're gonna start with the base. So the target path is the base path, and then we're going to copy. Is it a method of path copy? Nope, it's an algorithm. Standard copy, which means I should be including algorithm. Copy the relative path from beginning to end. And this is where it's going to look a heck of a lot weirder than other stuff. This is back inserter into the target input path. What that does is for every element of the relative references path from the beginning to end, for each one we're going to give it to this back inserter. The back inserter does is it takes the target path and inserts every element from that's given into the back. So it's effectively concatenating the two vectors. Now I feel really stupid if I could actually just do plus equals, but I don't think they have that in the standard library. I don't think that actually works. If it did, though, I'll feel so stupid. No, they don't. Great, save for another day. Okay, then we need to normalize the path. Copy the query from the relative reference. Copying the authority from the base. Okay, so that authority was this host. I should say a lot of this I'm just blindly translating. I'm not really thinking about if this is correct or not. And one reason I can do that and get away with it is my unit test will catch me. If it fails, then I have to step back and think, okay, what did I do wrong? You know, one thing I'm still getting used to is having my voice go for more than an hour and a half. Finding that alone is difficult to get used to. All right. I think that's it. I've faithfully and mindlessly almost translated their pseudocode into the methods and parameters and elements of our class. Let's see if our test passes now. It does not pass. All right, so yeah, my energy level stays okay. It's just my voice gets tired. Maybe I just talk too much and I'm normally not used to talking as much. Okay, so I couldn't just mindlessly let this pass because it didn't pass. What I really could use is that print2 to have Google Test print out all the elements, but I kind of wanted to save that for another day, so I'll do the next best thing, which is to go into the debugger and actually look at the difference. Okay, so the actual target URI. Scheme was G. Okay. Did it say which test? Oh, it's not index 1 that failed, it was 2, so hit go. Okay, so the scheme is HTTP, that's correct. User info is empty, host is A, that's correct. Does not have a port number, 5 elements in the path. So it's slash, okay, the A. got chopped off. Well, that's interesting. It's supposed to have chopped off the D's. Oh, okay. I didn't merge the paths correctly. I just did a concatenation. But really, actually, I should have remembered this. I was going through this before, and I was saying if this is the base, literally this is the path. If you give another name, it's relative not to that path, but the directory, so to speak. In other words, all but the last element. So I need to not just concatenate those two. I need to take this, chop off the last one, then concatenate them. So that was in my back insert thing. So before I do the concatenation, I want to chop off the last part of the path. I want to be careful though because it might be empty. It's only if it's not empty. I don't think it's possible for it to, no, it can be empty if you had something like, in fact, let's make a test vector for, no, I need a different base. Maybe I should just put base into this. Oh, I'll do that later. Do that later. First I want to fix the code. If this path is not empty, we want to pop the end off the path. Pop back. Let's see if that worked. Hey, check that out. That's exactly what I'd like to see. Whew. So, let's beef it up a bit. Let's do what I was going to do, but first wanted to see the test pass before I did it, which is I want to put in a test for if the base, this is going to become the base now. I'll put it in here now. These both had the same base because they're straight from the RFC. I want to have a base that looks like this. Example.com and just ends there. Because there's an example where there's no slash, so the path is completely empty. It's technically not an absolute path at all. It's just relative to the authority. And then we add something like foo. What we expect to get is example.com/foo. I'm thinking that's going to fail our test, but I'm not sure. So, oh, and I need to add the base here. Base string. And instead of initializing it once, we got to do it in the loop now. We can combine it with these other declarations and parse it there. And it's test vector dot base string. And it failed. I was thinking it was 50-50, either pass or fail. So let's see what happened. That would be here. Index 2, right? Yep. So the actual target URI ends up being http example.com. Path has one element, which is foo. Okay, so it didn't put the slash in like it should. I think this is a special case because usually a URL will have a slash after the authority, like these. Here's the case where you don't. And that's actually a special rule in the syntax. I think it's path AB empty, yeah. Path AB empty means it's either absolute or it's empty. I interpret that as being it should be absolute, but if it's empty, it's sort of a shorthand for it being absolute. But I'm not entirely sure. So let me look and see if they talk about it anywhere in the RFC. Although the path may be empty. When authority is present, the path must be either empty or begin with a slash. They don't say, though, if it's empty, what does that actually mean? Empty. Huh. Do they say the word empty at all? Okay, this allows an absolute URI to consist of nothing after the scheme. Okay, so it's really invented for that reason. Oh, wait a minute. If ref... Oh no, that's something different. I'm gonna, since they don't say it explicitly, I'm gonna assume that it's what you would expect, and that if it's empty, it ought to be interpreted as if you had put a slash there. So let's make a special rule for that. In fact, I want a special test for that. Sort of give it a first-class status as an expectation. And then if I learn later that I misinterpreted the spec, I can point to this test and say this test is the bad requirement. So the test is that empty path in, what do we call it, a URI with authority is equivalent to slash path, slash only path. So might be too long of a name. I don't mind having longer names. When I look back at this a year from now and I'm not sure what the test was, I'll be happy that I can read that. Okay, that's what that test was about. So our test is going to be URI1 and URI2 and okay, assert true. This is where it would be handy to have macros that just auto type this stuff for me. Assert true that URI1.parse from string example.com and 2 is where this got a slash. I want it to be true that they are equivalent. That one is really just a shorthand for the other. And I think what the standard was saying, in fact, we can make another example for that. I think what they're saying is if you have something like your n ABC, it's sort of the equivalent of saying your n. I'm not ABC, but your n, it's like the equivalent of saying that. And that's so that you don't have to have that slash. I think that's true. So this should fail our new test, and it does. So let's go fix it. Really, it's just a simple check at the beginning when we're parsing our path. Where do we do that? Parse path. Okay, so actually I already had a special case for if it was just slash. So really, all we need to do is say that there are two strings where it's allowed, where we want to interpret it as a single empty string element to indicate that it's absolute. If it's a completely empty string, oh, actually, not just that, but let me think about this. Parse path doesn't know if there was an authority or not. That's important because it's only for absolute URNs or URIs where we want to have this special rule. So maybe we don't want to do it here. Maybe we want to, I know, we want to do this after parse path is called. And it's here. So what we want to do is handle this case. We'll even say handle special case of absolute URI with empty path. Treat the same as path. It's just a slash path. So it's if the host is not empty, but the path is empty, then to treat it the same, all we got to do is push back empty string. Okay, now I failed another test. Oh boy. Which one did I... Relative versus non-relative paths? Okay, first I want to see why aren't these equivalent? Why aren't URI1 and U2 equivalent? They look equivalent to me. What am I not seeing here? Okay, they look the same. Okay, let's step in and step into that comparison. Scheme's the same. User info is the same. Host, example.com, yeah. False, false. Okay, that path is one empty string, and this path is also one empty string. Query's the same, and fragment's the same. So assert success. Oh, it wasn't failing on that one, it's failing on this one. I think. Oh, right. It's absolute, not because it has an authority, it's because it has a scheme, right? Or either one. What does the syntax say for URI? Actually, I had that in my VS Code notes. It's a relative reference or it's a URI. URI, okay, it has to have a scheme. That's what it is. It might not have an authority because hierarchical part could not have. So it's scheme that we want to test with. It's if the scheme is not empty. Okay, so the new test we added passed, but the relative versus non-relative is now broken. I think because I had a wrong assumption in there. Yeah, okay, so I had assumed that these are both absolute and that these are both relative, but this one's not a relative path. That was actually a bug from that test we never caught. Oh, hold on. Relative reference, it is a relative reference, but it's not a relative path. So which one did it fail on? 2? No, that's reference resolution 1. So it failed on this one. It thinks that that is not a relative reference. It thinks it is a relative reference. Okay, so what? Something wrong with our is relative reference. Scheme empty. Eh? Okay, let's see what line exactly at 170? Oh, I'm not looking at the right test. It's this test it failed on. Relative paths. Okay, yeah, it makes more sense. This is not a relative path. Oh, okay, here's where it is. We just made a rule that that's shorthand for that, so that's not a relative path, so neither is that. That's what it was. Okay, so down to just resolving a reference, and it's reference to this one. That is because, actually, why is that? Thought we would have fixed that by now. Let's see. It failed on line 668, so that they're equal. Okay, so let's look at that. All right, so actual is just foo. Okay, it still didn't add the absolute. Let's see if the base was correct. Base should have a single empty string marking the slash. Oh, I know why. Remember when we did the merge of paths? I did a pop back if it wasn't empty. Yeah, so we only want to do that if it's, let me think about this. We don't want to do it if it's not that it's not empty, it's that the size has to be greater than 1. So if the size is less than 2, and really if the size is 0, it's not an absolute reference, and we really shouldn't be using it at all. The base URI for a target resolution needs to be absolute. Otherwise you'd be saying like, you're resolving dot dot merged with dot dot. What does that mean, right? It's not an absolute path. Should probably add a test for that. Do I have it set up so that resolve can fail? No, it can't fail. Okay, so let me at least make a note here. This method only makes sense. It only makes sense to call this method on an absolute URI. Call this method on absolute URI, in which I mean the base URI should be absolute. As opposed to it being a relative reference. So we expect is relative reference to be false. In other words, in which we mean the base URI should be absolute, as in should return false. All right, I think that little note there, it's not perfect. Really should do is have some kind of check. But I think it'll be good enough to pass our test, and it completely broke everything. 2 steps forward, 3 steps back. Okay, let's see what I did wrong. All right, so normalized path is broken. $634 for the very first one, so it didn't like this. Should have been UAG and was AG, A, B, C, G? Eh? How did I screw that up? Old path is all that stuff. Good to have the watch here going, so it's building it up. We get slash A. Slash B. That was the dot, right? Or we already skipped? Did I skip too far and already? No. Okay, it's the dot dot. So, oh, did I? Oh, yeah, I changed the wrong line of code. Oh, what happened there? That belongs down here. It wasn't that place. Must be getting tired. I'm in the completely wrong function. It was when we were merging. It was this one right here. I'm surprised no one called me out on that. It's if it's greater than 1. How come that's still failing? You were calling me out in a very tiny voice. You know, I wish I had a point system. I need to set that one up. Consider yourself having an extra point. Let's see. I really didn't expect normalized path to break. Okay, now I'm starting to feel like I did something in Git to hose normalized path. So let me take a look. What did I do? It wasn't that. It was. Oh, I did. Look at that. I screwed up the bang right there. So here we'll do this trick where I find that unintended thing and unstage it, and then revert that. That was it. Ah, I made me sweat there for a while. Well, actually, Adam, thank you for not paying close attention because my brain went somewhere else and I really wasn't doing very good development there for a while. But it looks like I'm back on track and my tests are passing and we're handling paths that are equivalent like this. And we're handling reference resolution, which leads me to the next thing. I really should pull in all the other test vectors from the RFC. But once that's done, let's check my notebook. What was I intending to do today? Resolve and normalize path. So this will be done and move on to IPv6 addresses. And then if I feel like I have more time, maybe go to the to-do list, otherwise refactor. Okay, now I definitely will have to, let me bookmark that link. Copy the clipboard. To do. Watch. There we go. Now it's not going to be forgotten. All right, so let's do IPv6 addresses, and then if I feel like I want to stay up later, I will tackle more of the to-do list. It would be great to get the URI component done, but I do want to reserve some time for refactoring because pretty much my very first broadcast, I was coding along happily and someone said, your code looks really messy. And I'm like, this is why I'm streaming. I don't get this normally, but I need someone over my shoulder saying, you really need to stop and clean up that code before you move on. So I want to reserve some time for refactoring. But now that our tests are passing, let me make a commit. Let's review what we did. So this was a broken test. That's one thing we fixed. Fix assumption about absolute URI with empty path having, this is too long for the summary. So fix assumption about absolute URI with empty path having, before it was assuming that it was a relative path. This fix assumption that an absolute URI with empty path, let me reword this, fix assumption that the path of an absolute URI could be a relative path if it is empty, or not could be, is considered to have a relative path if the path is empty. You can't see or hear anything now? I'm sorry. Coincide with opening a program? Well, OBS says my mic is hot. So, gosh, I hope nothing's wrong on my end. And my buddy's not online to check. Let me, just to be abundantly safe here, let me do something. Well, thanks for stopping by, Adam. I really appreciate. We were really nice earlier when I was just thanking you for inspiring me to do this. I really didn't expect or any of that that you mentioned it, but it was wonderful to hear from you. Thanks. Enjoy your vacation. I'm looking forward to seeing your music stream tomorrow. I'm going to briefly jump onto my own channel to see if I can hear myself. I'm going to. Yep, I can hear myself. All right, so I'm sorry, Adam. I think it might be on your end. Let me type that. All right. Okay, what was I doing? I'm fixing an assumption. That's basically what I did. So fix bug and test, and then this will say more specifically what I did wrong. All right, so the other thing that I did, I did two things. We added reference resolution. That's the one thing. The other thing, right. Well, this one was easy enough. We'll stage that one first. Actually, that was part of the other thing, wasn't it? No, it wasn't. It was specifically something I added here. This special case. Right. Oh, and I added move semantics as well. We need to capture that as a separate commit. This commit is about recognize special case of absolute URI with the empty path. Such a URI should be considered equivalent to a path of / because in both cases the path is an absolute path. All right, so I added move semantics here. Or really it's define move or allow default move semantics for URI. And finally we added resource resolution. Just getting my thoughts together. So add reference resolution. That's basically all I did. Actually, I'm going to keep that staged, but not check it in, because before I do, I want to add some more of those test cases from the standard. So 5.2.2, right? Or 5. Do I have a... I don't have a reference in my comments. But there was a list down here somewhere. Here it was. So we're going to copy more of these things. That same base, but with slightly different relative reference /. And then g slash ends up with a slash at the end. And then slash slash g ends up with a very different URL. This one is here's one where I'm not sure it'll work. So let me stop there. And it didn't work. And yeah, it was 0, 1, 2, 3. Actually, it failed. Yeah, it failed right on that one. So I must have screwed up on. Oh, I think I remember what it was. I made a mistake up here about the authority being empty. The authority is. What? That's the same as that, isn't it? Let's look back at the standard. If the defined scheme defined, aren't they both defined? Confused. Oh, it's only authority if it's got 2 slashes. Okay, so why did the test fail? That should have replaced the authority, right? Oh, did I have a bad copy paste? R and R, okay. Oh, but not copy the scheme. Did I copy the scheme? No, I didn't. Did that not get parsed correctly as a host? Let's find out. Breakpoints, clear that. Let's put it right before the resolve. No, right there. We'll go to index 4. And let's see what if the relative reference URI was parsed correctly. Host G. Okay, that is correct. So what's the actual target URI end up as? Okay, that's what I thought it would be. What's is expected target URI different? Well, it's got a path in there of a slash. Actual does not. Okay, that's a problem. When it formed that, it didn't add the slash at the end. Hold on, but the. Oh, did I make another mistake about. Damn, I think I did. So back to the syntax. URI is a scheme. No, URI is absolute. So if it's slash slash G, what does that make it? It's a relative reference, but it's a relative reference with an authority. Okay, yeah, in this case it is a absolute. So the special case is where it has an authority. I see that, yeah, both in a relative reference and. Oh man. Okay. So that these special test cases, URI with authority is equivalent to a slash. URI with authority is equivalent to slash only path. Antipath and URI with authority. Okay, so the problem is that my special case is only working if the scheme is non-empty. But if this is also something that where they should be equivalent, it's that they have an authority part. So that means that my original, what I had before should have worked, right? It was, no, I'm getting confused. It's that special case. Handle special case of an absolute. It's not absolute URI, it's special case of URI with authority. and empty path treat the same as slash, so it is that. If it has a host name, it's got an authority, because host name is required. $683 is still failing. Okay, that's URN. Yeah, those are not considered equivalent. That was an erroneous case. Although I could make it correct. It doesn't matter. Doesn't matter. Those are the two paths we want to test. It has an authority either whether it has a scheme or not. Consider them equivalent. Okay. Glad I cleared that one up. Don't want to get too far into this stuff without making sure my requirements are correct. So I'm actually glad I didn't commit that, because having the full test vectors is helping out. Okay, let's see. Where was that list again? And what was I on? I was on /sg. These are all. Are these worth doing? Maybe, maybe not. Let's see if I can do them quickly, I'll do them. It's %y or $y, g $y, and the same thing but for fragments. Why not? I'll probably do this myself anyway. Try to hit all these different combos. That's a funny one. The semicolon is not really even a special marker at all. It's just a normal character, so it should be treated as just equivalent to the other cases. Okay, here's a couple ones I really do want to. I want to test empty string. I feel like that's an important. Oh, what happened? That's an important test case. And so are these other ones. These are tricky cases. Dot slash g. Dot. There we're getting a little bit too redundant. But why not? I'm almost done. If I don't screw this stuff up. Okay, so that's AG, that's just A. What's interesting is sometimes they have a slash and sometimes they don't. I think that it doesn't matter, they're all equivalent. Oh, no, they're not. No, they're not. If the path was empty, it would be equivalent. Like, yeah, I don't have to have a slash on the A. But these other ones, it's not the only path element, so it matters. A, B, C. And this is the full thing. A, B, C, D, semicolon, P, question mark, Q. I feel like I skipped a few. Did I skip some? I did. Question mark, Y, S. Is that? And it's the same thing, but without the query. This one's almost the same, only there's no G. And this is that. Probably best I just copy paste them so I don't make any mistakes. All right. Now we got the entire set of test cases, don't we? I'm going to mark these. These are all taken from section 5.4.1 of the RFC, which I have here. Here's an example of our, oh, no pun intended. Here are some examples of our own. And just to hammer that point home, all these different combinations, right? And then that again with the slash in front of all of them. These should all be equivalent. Hope I didn't have too many test cases and cause too many to break at once. All right, well, we failed on 5. 0, 1, 2, 3, 4, 5. Interesting. So that should have just replaced the query. Let's see why. So there. Need to have that print too. Would really be handy now. Actual. Okay. The path got chopped off. Expected. Expected has 4. So what happened to the path? Path is empty. The query's correct, right? 0, 1, 2, 3, 4, 5. Yeah, the query is Y, but the path got chopped off. That's weird. Oh, I actually wanted to see what the relative URI translated to. Relative reference URI. Right, no scheme, no authority, no path, just a query. Let me rerun and see what actually happens when we resolve that one. So scheme is empty, host is empty, path is empty. Target path, oh, that's not right. That is not right. That's probably a copy paste bug. Path is empty, it's base path, right? Not relative reference path, base path. See if let me double check these other ones. Either relative or base. Okay, that was probably it. Okay, we got further. Now we're at number 7. 0, 1, 2, 3, 4, 5, 6, 7. It's fragment. It should have appended the fragment. Okay, let's see what happened. Let me make sure the relative reference is correct. It was just S, right? Yeah. 1, 2, 3, 4, 5, 6, 7. It's just S. And what did it end up as? It didn't get appended at all. So let's look at where that should have happened. It should have happened right here. Oh, it's it was reference. Relative reference dot that. All these typos caught by my test cases. 14. Okay, we're getting much further now. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Dot. Dot did not remove the last path element and query. Really? What did it do? So let's look. Path is BC. That's correct. Actually, looks right. What didn't it like? Oh, it should be absolute BC and then another element, an empty element afterwards. Okay. It's how those paths are merged. If the last, it's okay. I think I know what it is. We only want to remove that last element. If no, we should remove the last element. So what happened? What happened? Why did it remove the last two elements? Is it because we merged it, added a dot, and then removed the dot? That might have been what happened. Let's, shoot. Already resolved it. Repeat. Let's go in there. Okay, so we are removing the last one off. And here, actually, I know that there's another bug. We don't want to pop the last one off if it is... Actually, no, never mind, we always do. Okay, so the target path is BC. The relative path is, it should be just dot, so it should add a dot. So now it's /BC dot. It should just remove, oh, is it removing the dot and not adding, making it a slash at the end? I think that's what it's doing. So there's the first element, B. C, right? And now the old path should just okay, it's /dot. Okay, here, okay, it's step 2B. Oh. So maybe I had something wrong in my step 2B of removing, what we call it, remove dot segments. I replace it with slash. Okay, it's not replacing it with slash. It is, no, it is removing it. It is, okay, so it should be just, it should be doing what I expect. Okay, so it is just a slash. And then when there's a slash at the very end, ooh, so this logic is not correct. So 2E. Oh, including the initial slash. With the first path. So why do I have it if the path is empty? Initial slash, right? Shouldn't it always add a slash? Oh, no, hold on. This is the special case, right? It won't be empty. It won't be empty, but it removed it, so now it... Is this the part that I need to remove? It's including the initial one, if any. I think it's that clause. We don't want that. That doesn't break a whole bunch of other things. It did, didn't it? Shoot. Reference resolution is this one. Okay, so let me think about this one a little bit more. Move the first path segment in the input buffer to the end of the output buffer, including the initial slash, if any, and any subsequent characters up to, but not including the next slash of the input. So this says, if the input buffer starts with a slash, we want to remove it. It should make sense that we want to put the slash into the output buffer. Right? I think so. So why does that not work? Let's find out why. Well, okay, so 634 in our unit tests. Where is that? 634. Index 0. So this first one fails. And ends up doing /a//. WSUBI, what is the web service for? Well, I have a couple different things I want to use it for. I have that in here under my notebook under plans. For the very long term, I want to make a Twitch bot, and I also want to ditch WordPress and make my own blog system. And I don't have it specifically written here, but I really like making things from scratch. And these are two things that are motivating me to not only make my own web server, which would be allow me to ditch the pre-canned ones you can set up, people set up for you on hosting platforms, but also with a Twitch bot, it's kind of like a custom web client, web server and web client being sort of twins. Once I have all the components to make web servers and clients, I can make my own Twitch bot. So yeah, just had the idea of making my own web server to do stuff on my own. Hope that answers the question. It's getting kind of late for me, so my brain is a little bit slow. All right. Yeah, apologize if I'm rambling a little bit. Let's see. Okay, the problem in my got a problem in my code in that. Did I already? Okay, I already stopped debugging. It's the way I'm running this algorithm. I don't really like I'm liking less and less the wording of this algorithm that the RFC gives me. I'm thinking about just ditching that code and doing this myself. Well, let's look into that. So what do we have checked out so far? Reference resolution. Okay, that's good to check in. This is all good stuff to check in. I think that this resolve is fine. It's just the way I'm normalizing paths is screwed up. Yeah, definitely do. Don't know C++? There's all kinds of different C++. I would call this almost like reinventing the wheel C++, where you try to use the bare minimum, just a language, just a standard library, and just code everything else yourself. Other people, when they think of C++, they pull down open source projects to do a lot of the basic stuff for them, and they focus on just integrating them. So there's a spectrum. I'm more on the side of I like to reinvent the wheel to learn things at a low level. That's where I am. So yeah, I was checking in my work because I think my tests are correct. I want to pull this stuff in too. This stuff is broken. I need to fix it. So we're just going to say we added reference resolution, which we did, and attempt to fix path normalization, but it's broken. Path normalization is hideously broken. Forked? Broken for now. So, not going to push that. I'm just going to ditch the code I had in there that was trying to be faithful to the RFC, and we're going to do it ourselves. So, essentially, what are we going to do? We have a path that has dots and dots in it, and we're supposed to collapse them. So I think the right thing to do would be to just process the input path one segment at a time. So for cost auto segment in the old path, there's going to be 3 categories, right? There are going to be normal path segments. There's going to be dot, which we can essentially just drop, and dot dot. So let's say if the old path, or if the segment, sorry, is dot, doing something else, if the segment is dot dot, something else, and in the third case, to do something entirely different. This one is most straightforward. If it's not dot or dot dot, we're simply going to push it back into the new path. Now, if it's dot, the way I see it, there are 2 things that you might want to do. Or are there? What do you think about Rust? I actually don't know Rust. I know absolutely nothing about it. Let me rattle off the list of languages I do know. Would you like to understand things, so are the perfect person to ask about it? Yeah, so there are tons of programming languages out there, and you happen to have asked about one I don't know, unfortunately. Yeah, there is a delay in my stream. Sorry about that. Maybe the next time I broadcast, I'll try doing it with low latency mode. Like, I'm interacting with the chat to me, which seems real time, but I know it's not, and in the back of my mind, I know that, and I just don't realize it all the time. I'm thinking that when we see a dot in our path, we just simply ignore it. So continue. We see a dot dot, then we're going to remove the previous segment we pushed in. Okay, so I'm now seeing your comment about focusing on X or Erlang. I actually have a friend at work. I have a full-time job. He's into Erlang, and I think that's great. I wish I had time to learn these other languages. Maybe I will soon. One thing about programming languages is after you've picked up 3 or 4, it's so much easier to pick up a 5th and a 6th. And you start to see a lot of things that are in common between languages, and start to appreciate what's different between older languages and newer languages. And also you kind of get a different perspective. Like I might go off and learn Erlang and then think, there are some things that Erlang does that I could do in C also, just the syntax would be slightly different, but I don't normally do that in C. Let's try to do it and see if it helps out in some of the problems that we're doing. So yeah, I really should make a list of languages and libraries and other things that I haven't looked into that I really should, because that is fun. All right, dot. I was thinking there are 2 cases, two code paths to think about for dot. If it's in the middle, it's going to eat the previous one we pushed in. But if it's at the front, we need to ignore it, essentially. And the front, there could be 2 cases of front. It could be dot, or it could be slash dot, right? In either case, we want to ignore it. So slash dot becomes just slash. Dot is just ignored completely. I think I'm getting that. I think I'm understanding that correctly. So we can code that by saying if the path that we're outputting to is not empty, then we want to eat the last element of it. Oh, what happened there? Pop back. Now, if this works, and that crazy logic that was in the RFC didn't work, I'm going to be kicking myself for not just doing it myself from the beginning. I have a feeling though that this won't work. Yeah, I was right. It won't work. Let's see why. Okay, so index 3 is 0, 1, 2. So this one expected slash b got just b. That's interesting. So it should have started out with empty string and then a, and then dot, and then b. So it should have pushed in empty string, pushed in a, removed a, added b. Instead, it removed the leading slash as well. So why did that happen? Let's look and see. All right, so the old path, 3 segments, slash, dot, b. The first one's empty, so we push it in. Second one is, hold on, I think I already saw the problem. Oh, I was looking at the wrong test vector, right? 0, 1, 2, 3. Okay, it's just slash, dot, slash b. And that should be, oh, okay, I see. Yeah, I forgot about that. I was talking about it, but it didn't connect in my brain. 2 cases, right? It's either there is a legitimate segment before, like this, b comes before the dot. The other case is where either it's the first path element or it's basically the first, but there's an absolute path placeholder. So we only want to pop the path back if it's not empty. And this is the case where it's not empty and either the size is greater than greater than 1, or that first element is not empty. Empty. Okay, that got past that. Actually, we're back to where I was a little bit ago. This test case back over here. Number 14. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. It's this one with the dot, right? The dot should have gotten rid of that last path element and the query, and it did something different. Okay, yeah, so what happened? Slash B C. Oh, okay, yeah, it didn't preserve the directory level. Okay, what I'm coding right now, we're getting into the really nitty-gritty details of this class called URI. I have a little top-level note about it. So URI is like the address of a website, or it could be a name of something. It's specified in this internet standard, and we're implementing a C++ class that can take a string like that and break it up into its various elements. We're going to be using this in a web server, for example, when we get the path part, separate it from the query, and then break the path into its segments so that we can route requests to the right service. Yep. So we've written all of the code to extract all the elements, and we're just getting into the last little bit of work that I had been not saving, but that was last to the more esoteric problems. Yep, essentially the class, let me show you that. Class URI here represents that URI, and it has a method to parse from a string, and then you can get the various parts of the URI, like the scheme, the host, the path, the port number, and all that stuff. And where did I get the spec from? It's what they call an RFC. It's made by the committee that reviews internet standards. They've been doing it for so long, the IETF. Yeah, I got the test cases from the RFC. So the IETF published these for free, right? And it happened to be in this section. They gave me a bunch of test cases. It's always nice to get the test cases in the standard document. Yeah, these test cases, yep. And when they're in the standards document, it's nice because I don't have to think them up. And I know that other people who've made the standard have put a lot of thought into it. Yep. In this case, it's really stressing my class a lot. I've been working probably the last hour fixing bugs in my code that are causing individual cases here to fail. So yeah, we're stumbling on this case, and it's where we're taking this base URI, and we're saying from that URI go to that relative position, and it's supposed to remove essentially the file name part off and the query name part, and leave us in this, if you can think of it as a path in the file system, leave us in the directory C, like in the directory, as opposed to, if it was that, it would be, I guess, the C element of the B directory, as opposed to that being the inside the C directory. So what's happening is it's being misinterpreted as the C element of B and not the C directory. I'm trying to find out what caused that. And I have a suspicion I know where the bug is, so we're going to take a look at that code. It's where I'm doing the merging of paths here. And I think it has to do with this condition here. So when we're merging paths, we start with, this is the base path. And then we're saying, well, if the path is more than one element long, we're going to strip the last element off. So in this case, the test case, this is the base path. So it'll be one, let me list out the elements. Empty string marking the initial slash. Actually, it's this initial slash, right? Let me pull it out here. So that becomes, that representing this initial slash, and then B, and then C, and then D semicolon P. So the rules say that when you say dot, you are supposed to take the last element and just strip it off. But dot refers to a directory, so it's like saying, actually that is the bug. The bug is that dot is not a file name, it's a directory name, so we really should add that at the end. If it was dot dot, then we would strip off one more directory and do that. I think that was the bug. So we already pop one off, but we need to add one back. Actually, that should have done it. It should have added a dot at the end. Is it that dot is not being replaced with a slash? That could be it. So what do we do here? We just skip it like it's not even there. I think that's the problem. It's if it's the last element, right? If it's the last element, we can't do that. So how do we check to see if this happens to be the last element? Well, thanks for watching. How do you say your name? WS Ubi? Thanks for following too. Hope you enjoyed at least part of what I'm showing, and hope you'll be back. Good night. Just Ubi. Gotcha. So yeah, a dot at the very end. We need to preserve that we're on a directory. So it's kind of hard to do that when we're looking at the path segment by segment. But if I rewrite this like this, segment equals old path dot begin, the more traditional way. Segment is not equal to old path dot end. Actually, even better. Even better would be to just even more traditionally size ti equals 0 is less than old path dot length size. And then const auto segment equals old path I. So if we only want to continue, if I plus 1 is less than old path dot size, it's probably a more elegant way to write it, but I'll put that in for now. Okay. Let's see why that failed. Didn't expect that. Case 14, and now put that back here. So we're in index 3 of the old path. So yeah, we're on the dot. It shouldn't continue, right? Oh, but it also didn't. Oh, yeah. Okay, so we need to do this pushback. And invert this logic. So it's basically if it is the size, push it back. And actually not push back that, but push back an empty. Caused another test fail. Number 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Huh. Okay, so essentially an empty path. An empty path is a special case. Right, that removing of the last one, where does that happen? In the merge? Right. Thinking that this is really problematic. I'm thinking that the merge is not as simple as just, well, it's not simple at all. I think the way I'm thinking of doing this merge is incorrect. The standard doesn't really help because it just says merge. Oh, actually they do have code here. Maybe we should follow what they say here. If the base has a defined authority component and an empty path and return a string consisting of slash concatenated with the references path. Otherwise, return a string consisting of the references path component appended to all but the last segment, excluding any characters after the rightmost slash in the base URI path, or excluding the entire if it does not contain any slash characters. Well, if it didn't contain any slash characters at all, it's a relative path. Right? I don't know why they even say this part. Not me to do my dog barking macro. Let me rewrite this. So we start with the base path. We're going to append the relative path to it. But before that, we want to pop the back. Actually, it's not just that the size is greater than 1. It's that the last one is not an empty directory. Can I say back? I can say back. Is not equal to empty directory. Because if it is, no, it's that it has to be. No, not. This is exceedingly hard to think about. If the last element is empty, that means it ended in a slash, and we don't want to pop the back. Yeah. So I think that's what I want. Ugh. And this is hard. Still this case, right? 10? 1, 2, 3. Empty path. So It should have popped this part off. Oh. If the path is empty too. Alright, so and the relative reference path is not empty as well. If it is, though, we want to keep it. Oh, it didn't do anything at all. Actually, I'm looking at this, and that doesn't look like the same test case to me. It got rid of the C somehow. BC. Am I not reading this correctly? I'm not, am I? I'm looking at the completely wrong test. I feel stupid now. So it was test case 10 here. 0, 1, 2, 3. It's normalizing that. Okay, that should be that. It was an error in my test case. That should be that. That should be that. All these test cases were wrong. Huh. I wrote this test case, I was not thinking clearly. Okay, I think that's better. $634. Number 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so normalized path. The last one's dot dot. If it's not empty, what's this doing here again? Expected A slash and got A. Right, expected A slash, but it actually popped it back when it shouldn't have. So when we're building this, again, it's A, and then B. Dot dot should get rid of the, okay. Should get rid of the, so it's not really popping it back, it's setting it to, it's inserting an empty one, right? No, it's replacing the back with empty string. Actually, that's not strictly correct. It's not as simple as I thought it would be. That eats just that part, but not that part. Oh, I think I see what's going on. So if it's the last, it's again, if it's the last element, right? If it's the last element, then make the back empty. Otherwise, pop the back. It returns a reference, right? Yeah. What if it's the only one? What if it's the first one? I have to be careful here. Only if it's not empty. Getting closer. Okay, finally getting past this quagmire I'm stuck in. So 699 is which test? 19. Okay. 0, 1, 2, 3. Okay, so from this path /b/c/that, 2 levels back should be dropping the last element and then going back to B, and then yeah, so let's see what it actually was. Oh, 2 slashes in a row. Okay. That's a good test case. I think it's when we're merging again. So here the old path is /b, c, ... So you would think it would just end up with slash. That's what it should do. So it puts in the empty one, then the B, then the C, then it pops C off. This one should pop the B off. Okay. Okay, because we're at the end. I think this is redundant. I think I was trying to solve the same problem in 2 different ways. This isn't quite right, is it? Thinking. The path isn't empty. If it's not empty, if it's a directory, empty directory, then we want to pop it. Otherwise, make it empty. Did that get further, or is it the same one? 19. It's the same one, isn't it? so the last one here goes in there. It's not empty. The last one, oh shoot. Why did we do all this stuff in the first place? We had that. Really, it's if the size is exactly 1, right? In fact, we want to combine it with that line above. It's in, if it's the last thing on the list and there's only one thing left. Grr. 634 is how this one's test. This looks familiar. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. This one again. This is Raimu getting stuck in his own quagmire of hacking code. It makes me think I need to step back and rewrite some of this stuff. Test cases I think are good, it's just the code is not correct, and I'm not seeing where exactly it's not correct. Expected a slash, right, as it should, and it ended up chopping off that last directory. Why? Oh, I see. Let's just rewrite this. It's too messed up. They just take a step back and think. When we're reducing a path, we see a dot dot. What we really want to do is if the last element was not. Actually, we just want to eat the last element in all cases, don't we? Unless there was no last one. Let's start off with that. If the path is not empty, this just wipe the last one off, right? Pop back. But we don't want to end up with a completely empty path at the very end. So I guess we want to see it right at this point, just like we did in the dot case. If this is going to be, if this is the last thing in the old path, then we want to push an empty one to the end of our path. I think that's probably it. I was just holding on to the code I had for too long. 634. Different test cases failing now. 0, 1, 2, 3. Dot dot slash B. We're normalizing that. Right, so that should be ignored, is it? The path. Oh, absolute path. Oh, right, we don't want there, that is a special case if for the very front. Yeah. We don't want to pop the special. Well, why don't we just pop it off and add it back? I'm tempted to treat that this special case specially. No. I don't think so. Hmm. Hmm. So let me try this. This is a special case where size is equal to 1 and it's just an absolute path marker. Then we don't pop it, so invert that. Greater than 1. Or it's not equal to that. Oh, that's not the code I had before, and I'm just recycling my errors. Okay, it wasn't, so it got to a different case. This time case 7. Dot. Ended up putting a directory path in there. So here we go. So if it's just dot, it's empty. Why are we pushing? Why are we making a directory at the end? If this is the last element? Oh, yeah. We do want to do that, but only if it's not empty. All these empty checks, all these special cases, I don't like it. 699. $19 again. Dreaded 19. The answer is 19. Oh, this was the dot. Oh, right. So it's if we eat all the end of the path. I think this needs to be another case of this thing. In other words, these clauses. Okay, that got past 19. 20 is there's a slash at the end. Two adjacent slashes ought to be collapsed together, right? What if we make that a rule that we can't push back we already sort of are checking for that, aren't we? Yeah, we're already checking it in a limited case, so maybe we should be checking it more in general. It's if here if segment empty or segment is not empty or path is not empty and the back of the path is not equal to empty string. Oh. All right, this I need to reevaluate again. I'm just not. I need to come at this from a different angle, or maybe do this when I'm not so tired. Let's undo that. That was bad. Back to it almost working. Hmm. So close. I just want to get this working, but yeah, this. I think I'd want to refactor this anyway. This is just horrible. Okay, let's start over with this. This is the problematic. Do I need to fix this up maybe? Possibly. These rules look kind of hokey. So we're normalizing a path. Let's go back to what we had before, where we're just looking at all the segments of the old path one at a time. Clearly, we handle if the segment is dot, or if it's dot dot specially. Okay, I think I'm gonna do this using flags. So we're gonna have a state where we're at the root. We'll assume we're not at the root at first, but actually we can check really quickly about this. We're at the root. If the path is not empty and the first element's also not empty. Actually, shouldn't we have a level counter for this? It's always going to be, when we normalize a path, it's always going to be, this is if it's absolute. It's absolute, we never want to chop off the front of the path. So, okay, I want to have another flag for if we're at a directory level or not. Let's say we're not at first, but if we have a dot, then or a dot dot, we're automatically at a directory level. Else we're not. Unless it's a slash. So we're at a directory level if the segment is empty. Okay, and we're getting there. So it's not dot or dot dot. We want to put it into the new path. If it's dot, we're at a directory level, but otherwise we don't do anything to the output path. If it's dot dot, we're at a directory level, and if we weren't, that's right, if we weren't at a directory level before, then we want to cut out the last element, which we can only do if it wasn't empty. Path dot pop back. Now when we reach the end and we're at a directory level, right. So if we're once we reach the end, if we're still at the directory level, but the path is either empty, or last element of the path is not empty. Whoop. What happened? There, lost my place. Then we need to insert an extra empty element to represent that, like a trailing slash, that we're at the end, that we're at a directory level. So here's my rewritten normalized path. Let's see how this stands up to my test. Okay, not much worse than before. Let's see exactly how it failed. So it failed in the very first vector here. Why? So it ended up, it should be /a/g. Ended up being /a/b. I didn't get rid of b or c. Did I forget to? Let's see. I forgot to pop back. Not at directory level. If we're at the directory level, I think I got this logic wrong. Don't really need this one, did I? Don't I always want to remove the last one? I think I always want to remove the last one. Okay, got a little bit further. In the right test. Normalized path, yep. 3, 0, 1, 2, 3. Okay, it made it no longer an absolute path. Maybe I did need that absolute thing. I had a feeling I would need that. We don't want to pop the back if, in the case it's an absolute path. So if, this is a special case, if it's an absolute path, and the path is, we're down to the last element, don't want. So if it's either not absolute, or it's greater than 1, yeah. So that errors it made an absolute path not an absolute path anymore. Okay, getting further. 7 now. Dot dot is ending up becoming an absolute path. Why is that? If absolute path is if it's not empty and the first element's empty. Well, that's non-empty and okay, so how did it end up with an extra one? Maybe it's here at the directory level. Ah. No, we don't want this one. Not if we're at the what I'm trying to say here is if we should be at a directory level and the last element is not an empty string, not a indicating directory level, then make it so. It's empty. No, we don't want empty. If it's not empty and the back is not empty. Okay, getting further now. Test case 20. // So the first dot should have wiped out. Let's see, that I guess. Well, really, it would have knocked out that and said we're at a directory level. Next dot should have knocked out that and said we're at a directory level. Oh, and then it added a slash, so it probably added an extra slash. So if we're already at a directory level, and segment is empty, then we don't want to do it. So invert it. If we're not at directory level or the segment's not empty, then do this stuff. Well, do this regardless, but do that only in those cases. Ah, finally passing all the unit tests. Man, that was painful as all heck. Whew. So what did I learn from all that? That I really shouldn't rush into trying to implement path merging and normalization and just be so cavalier about it. I really needed to, whenever I was getting into the weeds, needed to stop, take some steps back, and if I really couldn't make progress, delete the code and try at it again at a different angle. I'm going to need to refactor this and kind of capture the essence of what these conditions are and make sure I'm doing it in the most efficient way. But now that our tests are passing, I'm really tempted to just check that in. This is describing all of the requirements and meeting them. Because we did have some errors in the test vectors, let me review the test vectors again. So here are the ones for resolving a reference. These ones are from the standard, so those should be golden. It's these that I need to double check. So that looks good. Yeah, those all look good to me. And these are the ones that are really tricky. So these two came from the standard. These ones I invented myself, so let's make sure these are still good. Absolute path A, but then back up and then go to B instead. And this ought to be ignored, so it's as if you said /B. That's the same as that. Why do I have it twice? Maybe I meant to say that. In which case it really should be that, right? And here I'm at A, I try to back up twice. It should be the same as backing up once. Yeah. All right. dot slash should be ignored. So it's the same as if I said A slash B, right? Dot dot's ignored. Slash becomes an absolute path. All of the, okay, so you're at A and then you go down to B and then you go back up, you're at A directory level. You're at A, B, and then don't move, you're still at A, B directory level. If you, so that's as if that was ignored. These are all the same as, these are the same as these, only there's a leading slash, so there's an extra empty string indicating absolute path. These are the same except for there's a dot in front, and the dot, basically it means it's a relative path again, so it should be the same as these. Right? Yep. Dot dot, it's the same as dot, it's ignored. And then I have some of these interior cases here where this dot dot slash eats that B slash, and so it's A slash B. Same thing, but two things. I have that gets ignored, and then directory level. These are equivalent because either you stay where you are and go up one, or you go up one and stay where you are. Okay, these all look good to me. Okay. I think we're good. So in the end, what did we do? First, we fixed some erroneous test cases. Fix erroneous, well, it's really test vectors. And then we ended up rewriting our normalized path, didn't we? Okay, there were two things. That's a special case I'll deal with in a second. But this was complete rewrite of normalized path. Complete rewrite of normalized path. The former algorithm was based on this pseudo code from the RFC, which is hard to follow, frankly. More suitable when the path is in a single string, not a sequence of segments. So what do we end up doing? The new algorithm uses two flags. Is absolute. Recognize that if the path starts out as an absolute path, it needs to stay that way. And the other flag is at directory level. Recognize that if we encounter a dot or dot dot, then it will be reduced by simply discarding it or going back one step, \up one step. But then we will be in a directory context, meaning that should we end the path at this point, there needs to be an empty string segment to mark that the end of the path is what's the right word? At the end of the path is reaching into a directory, not looking at the not referring to, not just referring to the directory, as in dereferencing a directory. If you have a trailing slash at the end of a path, you're reaching into that directory. If you don't have that trailing slash, you're referring to the directory if it is one, but you're not reaching into it. Okay, so that's what we did there. This other little change, I have to remember where that was. So that's around line 816. And that was, okay, that was where we were resolving a reference, right? Resolving a reference, and my brain's sort of foggy. I'm trying to read this again. Okay, if the path is not empty, so basically if it's an absolute path, okay, in the standard they refer to it slightly differently. They say if the path starts with the slash. So this means if the path starts with the slash. Maybe I should annotate it. RFC describes this as if the path begins with a slash, then do that. It's in this else, right? It's in the merge. Let me mark that up. RFC describes this as we're merging the path. So it's when we're merging the path. We're starting with the base. Yeah, so it's actually, I wonder if we still need this logic. If the path is more than one element long, and the last element is basically saying if we're not at directory level, like that's what we called it in the other function, right? If we're not at directory level, right? Not directory level, and the relative path is not empty. So we're basically putting it back to directory level. That's what we're doing. And we weren't doing that properly before. Where is it? Before we were just doing it all the time. And the problem with that was what? It was always chopping off the directory level. Does that make sense? What happens if we don't? I want to see what happens if I stash that, and what test does it break? Because I don't remember. So git stash, not from that window, git stash from here. I'm just curious to see what test cases that breaks, if any. Maybe we don't need that change. That might have been a red herring, so to speak. It was a red herring. I'm glad I checked. So we didn't need that code at all. Git stash drop. Excellent. Although I did lose my little references, didn't I? Oops. Let's get it back. Learned how to do this earlier today. So git reset hard. This guy. And we'll go into git GUI here and say amend. I want to keep those things, but I don't want this actual change. So unstage dot discard. So we do want this, and it's not work in progress on top of that. What it is I wanted to document parts of the path normalization process. Add comments that link parts of the code back to lines of the pseudo code in the RFC to make the code easier to read, or easier to understand, at least for me. Okay, now let me look at git k to make sure. All right, it actually, I guess a stash ends up being a merge of an index, which is empty. So let's clean that up. That's easy enough. I just reset the here and cherry pick that. Reset hard to there, cherry pick that. Didn't like it. What if I just want that diff and I don't want... How do I avoid merging in an empty thing? Just what's exactly the error message? It's a merge but no M given. So what if I just do it on the command line? E9FED. Expects a number greater than 0. One, I guess. Okay, I think that did it. We got the change resurrected from the dropped stash. Cool. Push that. Build up. Get the comment back. Build it. Run my unit tests. All passing. Excellent. All right, so let me go back to my notes and see where I was. What I plan to do today. So I really only managed to do that, and what I did is I got stuck, which was a good thing. I got stuck because I thought I had finished it. It was passing, and then I said, oh, I'll just add in a bunch of test vectors just to be thorough, and then that exposed some pretty bad bugs. It took me a while to fix those bugs. I was going to get to IPv6 address checking, but gosh, it's getting kind of late, so I don't think I'll be able to get to that. So what we'll do is we'll push that off to next time, which will probably be Wednesday. Probably Wednesday, 8 p.m. Pacific. So we'll be wrapping up the stream in a little bit. Let me review what I did and talk about what I'll be doing next time for anyone who's viewing. So working on the component of my web server that's parsing URLs, and we're getting near the end of the component. There were some new methods I needed to add. Normalize path is to get rid of things like dot and dot dot in path names. Resolve is where you have two URLs, one that's a base and one that's like a reference, a relative reference from the base, and it combines the two. Spent a lot of time to make sure I got that right. There are a few things left to do, like checking for valid IPv6 addresses in URLs. And let's see what the to-do says. Need to refactor some of the state machines and other things in the code as well. I'm thinking do some refactoring. I need to invert the process. Up until now, we've all been parsing URIs from strings. Now I need to generate the strings from the URI, which is going to be hopefully a lot easier and a lot more fun than this parsing business was. And I have a note here that some hex digits are lowercase and some are uppercase. I have to be careful about that. I wanted to add some quick and easy standalone unit tests for some classes I broke out to their own functions, their own modules last time I streamed. I forgot to set up standalone unit tests for them, which is a good idea. I need to do that. I have I think these are more like wish list items. Because technically I really don't, at a low level component like a URI, I really don't need to double check the UTF-8 encoding. That ought to be the the system using this class should be just giving me valid UTF-8 from the start. So this is more like a wish list item. The less than in order to have sorted sequences of URIs would be nice. These are both wish list items. And then the print to, that would have really helped me tonight, so that when my test fail would actually print out the decomposed URI elements for me so I wouldn't have to use the debugger to see it. I guess these I should group in as wish list items. I need to watch this link that Adam gave me, and that is unrelated to URI. So let me remove that. A new page. Viewer suggestions is what I'll put it under. Failure messages that get chopped off. Failure messages. Got chopped off of that. Alright, so I don't know if I'll get to the wishlist items or not. I think if I get these done, I'll consider this component complete, and then I'll move on. The next after this component will be on my short-term plan to working on internet message component, which is a different RFC, and that covers email messages and web requests and web responses. So it's pretty important for our web server and web client stuff to have a class that can parse HTTP requests and HTTP responses, and maybe even emails in the future. They all use the same standard. So I'll be working on that. Eventually I'm going to need this, so I'll get to it short term as well. Just a component that can encode and decode UTF-8. That's not too hard. Done that one before at work. Those are the short-term goals, and then moving on, there's a component that I've already written for a hobby project I want to bring into this stream called system abstractions, and I'm going to be using that quite a bit when we're working with network messages, formatting strings, reading, writing files, monitoring directories, subprocesses, and then some miscellaneous stuff like target platform info and measuring time. I need to bring in that library and kind of clean it up. I'm going to treat it as what I call legacy code. It doesn't have unit tests at all. I was horrible when I wrote it. I didn't write any unit tests. So we're going to establish tests for existing code, and then we're going to refactor a lot to clean it up. Once we've done that, I can actually start working on the real web server, because we'll have these requirements all set up. We'll be able to actually make a piece of code, a program that can listen to a network socket, interpret what it reads as an internet message, HTTP request, validate it, generate a response, send it back out. We'll be able to do that because we will have all of these components that are required to do that all set up and ready to go. Once I have that, I'll actually have a real web server, which will be cool. And I want to start adding some cool things to it, like dynamic content and WebSockets. So dynamic content, that's plugins for the web server that are called when the paths that are given to the server match certain strings. So like you might register a web service foo. So if your web server is asked to give out the response for /foo/bar, we'll parse that path, take off the bar part, find foo, and call foo and give it the bar part. That allows us to make plugins so that we can have several different plugins that respond to different paths, and then the web server part can be generic, and we put all of our specific dynamic content generation in plugins. And then the other thing I wanted to do was WebSockets, and which is a really cool thing to do bidirectional communication between web servers and clients. And that's similar to URI and internet message. It's covered by an RFC, an internet standard. So we'll be implementing a class that basically implements that standard. And the way WebSocket works is it takes over a connection established between a web server and client if that connection is upgraded. There's like an upgrade protocol. So if during the upgrade protocol it requests to be upgraded to WebSocket, the web server will say, okay, make a WebSocket, and then hand the connection to that to deal with it. We'll be able to do some really cool things with WebSocket, for example, making a simple chat room, and then probably eventually making our Twitch bot, because the way I understand it, there are a lot of WebSockets in addition to normal web connections that are involved communicating between a Twitch bot and the Switch servers. And then long term, I have to do some research on this, but I want to support secure connections. Yeah, I just mentioned this. I want to make a Twitch bot out of the components and pieces we're making now, and eventually want to ditch WordPress and make my own blog system purely on web stuff I've written myself. So that's where we are, where we're going to short, medium, and long term. Under this history tab, I'm going to be, after a short break, probably tomorrow morning, I'll go in and type up a retrospective. I'll think back to this stream and what I accomplished, how I struggled with it, what I learned from that. And then I'll set up my plan for the next stream, which will probably be, again, Wednesday, 8 Pacific. So what is that? Roughly 44 hours from now? And if you're curious, this notebook is available for anyone to view. There's a link to it below. And let's see. Did the wrap up? Planning to stream in 2 more days. I think that's about it. So I hope you enjoyed watching. If you're lurking, if you're following, or if you're watching this non-live, like later through YouTube or whatever, thanks for watching. Appreciate it. And one parting thought is I really do enjoy doing the live streaming of programming. I've programmed for years and years, but mostly it's been solo and with no interaction with anyone. And it can get really difficult when you're stuck on a problem and you have no one to give you ideas or to help you out of it. Or even if you're not stuck yet, but you're on your way to getting stuck, if you don't have anyone there to say, hey, hold on, that code's getting messy, you should stop and clean it up first. I really missed that, and so I'm hoping that to get that out of the live streaming. So I really appreciate everyone watching, and especially if we have some interaction, maybe tell me when I'm doing something stupid, or tell me if something I'm doing doesn't make sense, or if you have questions. I'm really looking forward to the interaction. So thank you, and I will see you next time. Cheers.